Personally, when I think of water heaters, this is exactly what I think of. I think of a tank type water heater, right? This little vessel that sits in a corner. It's like the little silent guy that, just does his job without talking a whole lot. That's a tank type water heater. That's what we see in the vast majority of the applications where water heaters are used. You can break it down into a couple different things, but you're looking at basically your little atmospheric rocket ship. Okay, so it's just your plain Jane water heater. Okay, you got a tank sitting on top of a burner, and that burner is just cooking the water kind of like a teapot, right? Gets up to temp, it shuts off. Easy peasy, lemon squeezy, no big deal. You move into the high efficiency world, you add a certain level of, I don't think complexity is the right word, but you've got added controls, added technology, you're stirring things up a little bit more, you're trying to get more energy out of it. But at the end of the day, it can still be very similar to just a tank with some, hot air going through it one way or another. The other one that's kind of common out there that kind of falls in a gray area is your power vented, okay? A power vented water heater, if you look, is still very, very similar to an atmospheric water heater. Power vented water heaters are sometimes confused as high efficiency because you can vent them with PVC, okay? You can vent them with PVC only because usually somewhere along the line in this blower motor up here, they're sucking room air from around there to blend it with the hot combustion gases coming out of the water heater to something cool enough that can pass through PVC. The efficiency of the unit has not changed. We're just blending it with cool air to be able to power vent it out the sidewall, okay? So, kind of like the three types you have, so to speak, in terms of tank type. Tank types can be very versatile, right? There's really no set where you can or can't use them. They're kind of like the workhorse, the tool that you can use most anywhere, okay? Can meet the demands of most small commercial buildings. So whether you're doing residential, which we all see them in those houses and everything else, even commercial. Once you move into that commercial, it'll handle a good sized building before we got to start thinking outside of the box. Relatively large BTU and storage capacities within a small footprint. So your tank type, again, you kind of have the burner and vessel all in one little cylinder, right? It's not like I got separate components all over the place. I set a 24-inch tank in place, 24-inch in diameter in place, and voila, I've got a water heater, and that's all the footprint I really need. Easy piping with cold in, hot water out, no minimum GPM required. So in other words, just opposite of the tankless, right? Where I need set GPMs if I'm doing a recirc, or I've got to have so much GPM moving through the unit before it's even triggered to fire. This is literally looking at, in its simplest form, just an aquastat inside of a large tank. When the water cools off, closes a circuit, creates fire, heats it up till the circuit opens and shuts it off. Very, very simple. I could have no flow or I could have a lot of flow. It doesn't matter. When to use tank type water heaters. And again, these are all just, the broad ideas. Every application is going to bring a little bit different answer, but at the end of the day, limited space applications. It's kind of, when you look at it compared to what I said in tankless, it's somewhat ironic or almost, kind of counteracts, but at the end of the day, it's true. There's oftentimes, especially in a retrofit, they have so much stuff on the wall that space is no longer usable. It could be VFDs, it could be electrical disconnects, it could be, shelving, it could be all these different things, so you lose that wall. A tank type water heater typically comes with very low service requirements and very low clearances to combustibles, so we can kind of shove it in a corner, get a fair amount of BTUs, a fair amount of storage, and life goes on, everybody's happy, okay? When you have inconsistent loads, right? Or you have ebbs and flows, whatever you want to call it, right? So the nice part about a tank type water heater is when you walk up to a faucet and you just want to wash your hands quick, I really don't have to fire anything. I don't have to create energy because I've already got it stored in this big teapot. So the hot water is there and I can just pull from it as I please, okay? On the flip side, if I want to fill a bathtub, right? or I want to fill a mop sink, or I want to fill something that has some, relative load to it or volume to it, I've got this stored volume sitting there at my disposal. So now I can take 65 gallons out of it that's already heated, or I can take 100 gallons out of it that's already been heated, serve my purpose, and let the heater catch up. Okay? You will also hear as we move into tank type and separate heater, separate storage tank applications, you will hear like first hour recovery rate. Okay? That first hour recovery rate is your BTU. So what can the unit overcome? Typically sized, again, you'll like this, right? So tankless is typically sized on like a 50-degree rise, right? Or maybe a 70 or whatever. When you look at actual traditional water heaters or even separate heaters, separate storage tanks, most commonly sized and promoted as a 100-degree rise. Okay, 40 degrees to 140. All right? So your first hour recovery is with the efficiency of the unit, the BTU of the unit, how much can the gas, right? So by burning gas, how many gallons per hour can I create? Plus, on the first hour load, it's that plus the storage capacity that I have. So like an old rule of thumb, when you have an 80% water heater, it was basically like 1 gallon, or if you had a 200,000 BTU unit, you could do 200 gallons an hour, roughly, okay? So if I had a 200,000 BTU tank type heater with 100 gallons of storage, my first hour recovery was 300 gallons, right? Because the heater gives me 100 gallons sitting there in the tank, I can pull off of it, and the heater can overcome a 100-degree rise at 200 gallons an hour. After that first hour, the unit now becomes a 200-gallon an hour water heater, right? Because I've soaked off that stored capacity, and now I'm basically making it on the fly. Okay, so there's two different recovery rates you have to look at. So if you have a dump load type application where somebody comes in and they fill a big sink or a spa or whatever, oftentimes you can get away with that first hour recovery. Okay, so I don't need this monstrosity of a heater because I've actually had all the time during the day to make this tank warm, and then I just suck off of that little bit extra, and then it shuts off again for an extended period of time. Okay. When you have marginal gas sizing, gas pipe sizing. So again, yes.
I know on that shield, you have 2 relief valves on there?
Okay, so the question is, for those of you online, is on this shield, do we have 2 heat valves? Are you talking relief valves?
Looks like there's one on top.
Right. So for those of you online, the question is, are there 2 relief valves? On this particular unit, yes, you're 100% correct. There are 2 relief valves. The reason being is, on this particular unit, it's a little bit different. Even though it looks like a tank type water heater, behind this black cover here is a heat exchanger, right? It's a stainless steel wound coil type heat exchanger. Right about here, there's a circulating pump, and from this line down is a storage tank. Okay, so this heater is a little bit different, but it kind of falls in the classifications of your, high efficiency water heater, right? Without going into great detail. So there's different ways people do things. This happens to be this manufacturer's way of giving you the footprint and the capacity of a tank type water heater, but giving you the benefits of a separate heater, separate tank. So correct. So again, the question for those of you online, and my apologies, my first virtual online thing, so I'm still learning that, right? But for those of you online, the question was, so there's a stainless steel heat exchanger up top and a carbon one below. That's more or less true in the sense that the heat exchanger is a 316 stainless steel heat exchanger, and the tank is a carbon, steel tank, but with a glass lining, right? So that we can put potable water in there. So, but at the end of the day, we consider it, a tank type water heater in terms of footprint and functionality, but with a caveat. So again, back to, if you have marginal gas piping, you can get by with a slightly lower BTU input of heater and rely on your storage to help during peak times. Okay, unlike an instantaneous where you need full input basically at any given time. And then when you have low GPM requirements. So if you have, again, if you have a bunch of little faucets, right, that are randomly used, one could argue a tankless makes sense. One could argue that a tank type makes sense, right? Do I really want to fire a unit every time someone goes in to wash their hands? You could. There's nothing that says you can't. Or do I want to have something with a little volume behind it that's already sitting there stored, ready to use, and I don't necessarily have to fire it? The argument's there, whatever works best for you. Okay? Probably the biggest caveat to tankless water heaters is inherent is not the right word, but the traditional design of a tank type water heater. In a traditional design tank type water heater, we've got a vessel, okay? And on the very bottom of it, we have a fire teapot, right? But unlike the teapot on your kitchen where the flame can just roll around and exhaust itself out, we have to put the flue gas or the flue gases, the combustion, products of combustion somewhere. So what do? We run them up the middle through this vent pipe. We then use that to our advantage in giving off a little bit more heat before we eventually leave the top. That design is very simple. It works, but it also can create a lot of potential for scale buildup. Okay, so in this unit here, it's kind of extravagant. Most heaters don't last this long before they kind of fail before getting there, but this can happen, and milder versions of this picture happen all the time. At the end of the day, you have this vessel and a fire underneath. That fire is precipitating all the hardness and all the scale impurities out of the water. And where does that stuff go? Settles right down to the bottom. As you start settling on the bottom, you start creating a buildup, right, of scale, which happens to be a very good insulator. And then that insulation keeps the flame from transferring, or the fire keeps that from transferring energy into the water. So now you put a ton of thermal stress on the bottom of that water heater. Any of you that have ever changed a water heater or in the service world or anything like that, the majority of the water heaters you replace because they're leaking come from right down here on the bottom. Very seldom are they leaking from anywhere else. It's always right here on the bottom. And again, that's because you have such a high intensity of heat. And normally we have water there to cool it off, take that energy. But as we keep cooking the scale and impurities out of the water, it creates a barrier, an insulation barrier. Now we have nowhere to put the heat, so it overheats the metal relative to the temperatures you'd find up here on the metal, stress and crack. Okay, so that's kind of the one thing if you're, it's kind of a love-hate, right? So a tank type water heater is very affordable, right? Very, very affordable, assembly line type thing. We just keep making them all day, every day. If your customer is not interested in softening water, doesn't want to deal with that expense, whatever the case is, one could argue this is the application for them because they're going to go through equipment no matter what they do. But if you just have, an 80%, an atmospheric type tankless water heater, it's also their most cost effective in terms of replacement, right? So they just know that every couple of years they got to take out a water heater and put a new one in. Sad reality, okay? If you have a tank type water heater and you are cognizant of the water hardness and you maintain your water, there's absolutely no reason it shouldn't last 20, 30 years. Really all depends on your maintenance and what you do to it, okay, and protecting that tank. The other thing to be cognizant of is, floor space. So in tank type world, we have, atmospheric and we have high efficiency. Each one comes with a little bit different level of service clearances, both for service and or clearances to combustibles. So maybe you don't have the footprint to put in this. Some new buildings, new homes even, are being built with a tankless already installed, right? And they account for that looking at the floor space. So now this heater fails or they want to upgrade or change or whatever the case is, but it was designed to be on the wall. You may not have the floor space to do it, right? Retrofit. I feel for the engineering community, especially, right? Or equally. They're constantly challenged every year with smaller and smaller and smaller and tighter mechanical rooms. And they move them from the exterior wall to further interior. So you're dealt with the same challenges. You just sometimes run short on space.